And tonight we're going to talk about consciousness and also the latest in cell research and how it is all tied together. Robert Lanza, our guest, his work, Biocentrism. And we'll talk with him in a moment on Coast to Coast AM. Prometheus sounds like a good movie right down our alley. Dr. Robert Lanza, currently Chief Scientific Officer at Advanced Cell Technology, also a professor at Wake Forest University School of Medicine. He has hundreds of publications and inventions, more than 24 scientific books, among them Principles of Tissue Engineering, Essentials of Stem Cell Biology, recognized as their definitive references in the field. Biocentrism we'll be talking about tonight as well. Welcome back to Coast, Robert Lanza. Robert, how are you?
Very good. Thank you very much.
Good to have you with us. Looking forward to this. This has a little bit of science and a little bit of just something different about the universe, and I'm fascinated with this. And you broach it with stem cell research, and you look at the cosmos. Mm-hmm. Tell me about the bridge. How did you gap the two?
Well, it's all part of an effort to understand life, and not just this or that cell or protein, but how did God make life in the universe to begin with?
A question I wish somebody could answer for me. You know? I mean, it's baffling, isn't it?
It is, and I sometimes think that we're still living in the Middle Ages. As a scientist myself, and I go in the lab, and we play with the petri dishes, but the big questions completely elude us, and we have no more of an understanding of what's going on than the first thinkers of civilization.
We're going to spend a lot of time talking about the biocentrism, but give us some updates. What's going on in stem cell research? This fascinates me.
Okay, well. The cell known as the embryonic stem cell, which is the body's master cell, was discovered about 13 years ago. And the beginning of this year, we published a paper in The Lancet. This was the very first report of embryonic stem cells being used to treat a patient. And in this case, we treated patients who had macular degeneration, which is the leading cause of blindness in the developed world, as well as a disease known as Stargardt's disease, which is the most common form of macular degeneration in children. So what we showed was, in addition to there being no safety issues, we were able to show actually that the vision of the patient improved after we transplanted those cells, even at the very lowest dosage. This was a safety study. So, for instance, before treatment, the Stargardt's patient could only detect hand movement, but within a week after treatment, she was able to actually start counting fingers. Indeed, before treatment, she couldn't read any letters on the standard visual acuity chart, but within 2 weeks, she could start reading letters. By 1 month, she could read 5 letters. And that doesn't really capture the difference this has made in their lives. So, for instance, the patients report that they can see more color. In fact, one patient started using a computer, can even read her watch. And little things that you and I take for granted can make a huge difference in the quality of a person's life. So, indeed, the dry AMD patient recently went to the mall for the first time. Another patient went to the airport and traveled on her own. Another patient says she can even thread a needle now, which I can't even do with my glasses. So some very exciting things going on. That's just in the eye.
It really is. And a lot of scientists now and medical professionals are beginning to harvest stem cells from the individual themselves, aren't they?
Exactly right, and this is known as cellular reprogramming. These are known as induced pluripotent stem cells, or iPS cells, and we have now developed multiple methods to do that. In fact, I published a paper with Dr. Kim at Harvard recently where we can actually now do that without the need of any viruses, so that they should be completely safe. And so the hope is to move into the clinic with those very soon.
We had one of our listeners, several listeners, but one specifically, Robert, could barely walk 15 feet without almost passing out. Mm-hmm. His heart was so damaged, he was on his last leg. Mm-hmm. My guest got him into a trial study of self-harvest stem cells that they injected into his heart, and he's jogging now.
Yeah.
It's remarkable.
Well, it is, and there's some very remarkable things that you can do with stem cells, as you mentioned, the heart and even for claudication in the leg. So, for instance, we've discovered a type of an ambulance cell with the amazing ability to repair damage in animals. So a single injection of these cells cut the death rate after a heart attack in half, and it completely restored the blood flow to ischemic limbs that might otherwise have to be amputated. So someday we're going to look back and they'll say, can you believe they used to actually cut people's legs off, and then the doctor will give you an injection of cells and save your leg?
Do you see the day, though, Robert, that one day, just as preventative medicine, we will all go in and get a stem cell shot?
Well, yeah, I mean, actually, these ambulance cells I was talking about are very smart, and if you label them and you inject them into the bloodstream, they will go to wherever the damage is. So if you've had damaged heart tissue, for instance, they will go to the heart, or in the eye where you can just look in, you can actually see within 24 to 48 hours that they go in and repair the vascular damage after diabetes. So again, yes, an injection of these cells would be very much like nanoparticles.
Oh,
it really...
God.
A whole new paradigm in medicine.
How close are we to that?
So we're working on that, and we have these cells that are amazing. Just to give you an example, just a couple of months ago, we discovered a new type of super potent stem cell. A single injection of these cells stopped multiple sclerosis dead in the tracks. Animals that were dragging the whole back part of their body that were paralyzed, we gave a single injection on day 6, and those animals were jumping around completely normal. So if you imagine, there are over 100 autoimmune diseases in humans that we might be able to treat with these cells. So, for instance, arthritis, lupus, diabetes, even chronic pain and heart, liver disease. We're entering a whole new era of medicine here.
This is dramatic.
It's exciting. It's an exciting time.
And there's no end to it.
Well, actually, these cells, these pluripotent stem cells, as we call them, are the body's master cells, and we can make virtually every cell type in the body, and not only to restore worn-out or damaged cells, but using a technique known as tissue engineering, we can actually reconstitute those into more complex tissues and structures, and indeed entire organs, such as a kidney or a heart.
If you injected a cancer cell,
right,
would this kind of cell attack it and wipe it out?
Well, there is actually quite a bit of published data showing that there are some tricks we can do. So, for instance, this new cell type that I had mentioned that we have recently been able to create in large numbers actually has been found in animals to actually to help fight cancer and to prevent it. So there are many ways we might be able to use this technology, and one of them, as you mentioned, is to actually hunt down existing cancer cells to kill them.
Is there a downside with this kind of technology?
Well, of course, we had to go through the FDA to get clinical approval. They're being very, very cautious because, indeed, the very notion that these cells can make every type of cell is of concern, because at that point, if you put them into, say, your brain and you create a tooth or a piece of bone, that's not so good. So they want to be very sure that your cells do what they're supposed to do,
right,
and that they're turned into the cell type that they need to be turned into.
But, but also, what would it do to pharmaceutical industries and people? If you start injecting stem cells that find disease and ailments and it fixes it, what do we need drugs for?
Well, the hope is someday you're going to be exactly right there. I mean, even these cells we're even believing now, and there's some data that suggests they can reverse arteriosclerosis. So yes, I think many of the chronic diseases, many of the ills and worn-out tissues that we have, these cells hopefully one day will repair that damage.
I've got a friend in St. Louis. She's got MS. Great person, just a superb family. How does she get into programs where she could be a guinea pig, basically?
Well, sadly, these programs take time to go through the clinic. So, for instance, we're talking about macular degeneration. The first clinical trials each involve 12 patients, and we have to go very slowly with only a very few cells to show. For instance, in this study, we were supposed to be just using them to show they're safe, but it turns out that they're actually helping the patients see. So then if we show they're safe, then we'll move on to do more patients, say a few hundred patients, and then eventually a few thousand. And that whole process takes about 5 years before it becomes widely used in the clinic.
So you could comfortably say within 10 years, usage of stem cells, maybe even harvest from within your body, may be just a common everyday thing.
This is true. Actually, it turns out that there is a kind of a stem cell bone marrow transplants that have been used for over 40 years that people use now routinely for cancer and other diseases. So I think that definitely these newer types of stem cells definitely are going to be more widespread than anyone imagined.
We talked about how stem cells can be used to repair heart muscle. What about the arteries that get clogged up? Could stem cells clean those out like Drano?
Well, this is one of the things we're looking into. In fact, we have this type of a cell known as hemangioblast that actually is a cell that existed only in the embryo. It transiently became all of your immune system and blood cells, but also the vasculature. And so by turning these cells into endothelium or these primitive vascular cells, we're actually able to now repair damaged vessels and actually, like you as you're hinting, reverse atherosclerosis. So these cells have the potential to fix many of the problems associated with cardiovascular disease.
Would we ever be in the form where you just pop these as like supplements, pills?
Well, no, actually, these are living cells, so they would need to be injected either, into the tissue or into your blood.
All right, but it would be like a shot.
Exactly.
Interesting. God, that's fascinating. How did you get into this?
Well, it goes way back to when I was a kid. I was very rarely
you love science.
Outside the house, and so I used to go to ponds and catch turtles and climb trees. And
I did the same thing.
Did you really?
Did you ever get little? Did you ever grab them as tadpoles and make them?
Oh yeah. We used to actually get the eggs and put them in our bucket and watch them hatch and turn into tadpoles. And they either didn't make it or we let them go back into the pond.
Yep.
Hopefully then they grew up to become frogs.
And you had a chemistry set?
Of course.
Of course,
yes.
A telescope?
Not one that worked, but I had one.
And you'd go downstairs and you'd tinker all the time.
Mm-hmm. Right. Yeah. I mean, I just had a great interest in nature and how everything went together and why things did what they did.
See, what I did what you did, except I also loved broadcasting, and I figured this is a way I can, cover these stories that I love. Mm-hmm. The stories of science and chemistry and things like that. And I went into that direction, and it was just, for me, it was phenomenal.
Mm-hmm. Yeah, well, I actually started working in my basement. I figured out actually at one point how to alter the genetic makeup of white chickens to make them black, and then transferring the genes into the pigmented chickens, and so it was exciting, and that led me into science. That work, I eventually went off to Harvard Medical School. Actually, that's an interesting story. I was just a teenager, and I saved up all my dimes and quarters to travel into the greatest place on the planet, Harvard Medical School, and I was going to talk to a doctor about how to do these experiments. And so when I actually got there, the god wouldn't let me in, and I felt like Dorothy in The Wizard of Oz,
exactly.
And the god said, "Go away." So I went around the back of the building, and I waited by the dumpster trying to look inconspicuous, and a short, bald guy came up in khaki pants, and I figured, he's the janitor. So I slipped in behind him when he went through the door, and he turns around and goes, "Well, can I help you, sir?" And I said, "Well, no, I'm looking for a Harvard doctor." I didn't know that this guy was Stephen Kufler, who was the chairman of the Department of Neurobiology. He had actually founded the department. He had been nominated for the Nobel Prize. Instead, I tell him, I'm good friends with the janitor who lives up the street, and I worked in the kitchen cafeteria. So as we got to talking, I told him I had altered the genetic makeup of chickens, and so he actually introduced me to this guy, Josh Sain, who now runs the Brain Center at Harvard. He was just a grad student at the time, and they invited me back to repeat my experiments, and eventually they were published in Nature, actually, way back in 1974, the year I graduated.
How old were you?
High school.
you what were you, 18?
Yeah, exactly. Well, when I did the experiments, I was a lot younger than that, but that was when I actually published the paper.
Fantastic.
And every now and then the janitor would show up, and I was always excited to see him. And it was only later that they told me who he was, which is a good thing. I probably would have run out had I known.
That's exciting. And where were you born?
I was born in Boston, actually.
Oh, my mother was born in Fitchburg, which is
really? Okay, that's
west of there.
Where I live now, west of the city. Yeah.
Yep. And I was every summer I'd be out there. Leominster,
I love the Boston
Worcester,
area.
all over. It was just great.
Oh, do you ever get back there?
She's there now. She just went to see her family and her sisters.
Oh.
I've not been back to Boston in about 10 years or so.
Okay.
But gosh, we used to love it. Just love it. And you remember they used to have these little clam stands like they have McDonald's all over the place now?
Yeah.
I mean, are they still out there, or have they gone away?
I mean, you can go up and down the street in the fall, for instance, too, and there's always the people growing their corn and food from their gardens that they're selling. So yeah, and there are definitely for clams and fish that you see here and there.
You a Boston Red Sox fan?
Yeah, I live here, so I guess that's what I'd be definitely cheering for.
Oh, yeah, you get to do that. Well, I'm going to talk with you in a moment about biocentrism, and you can explain to us what that is, which is, of course, tied into the universe in your theory. And it's going to be fascinating for you to tell me how you made that evolutionary jump from stem cells and science into looking at the cosmos and things like that. But as we just wrap up talking about stem cells as well, are we, and are you, as a scientist and as a doctor, are we being supported by the government to get this stuff done?
Well, I think everyone has heard, that particularly back in the Bush era, that, there was virtually no funding for this advanced stem cell research, these embryonic stem cells. It got caught up in all of the abortion politics. So, all this research has been held up, at least a decade. I started out doing experiments over a decade ago where we injected some of these cells. This was an experiment that was done at Harvard where we injected them into a sheep model of what's called spinal bifida myelomeningocele. And these animals normally are born paralyzed, and there are kids that are born in wheelchairs. And the first injection we put into those animals, that animal was born walking fine. We didn't have the money. The government didn't fund that. And, I always wonder today how many people are in wheelchairs that are paralyzed because we didn't fund this.
That's right. What about other countries? Are they ahead of us?
Well, for a while, we started losing scientists. They were going to the UK, to Singapore, and elsewhere. Things have started to turn around. There's more money now being used for this. Since Obama got in, they've increased the amount of money being used for this. So I think we're in a little bit of a race, but I think right at the moment we're still ahead, although they are forging ahead over in China and India and elsewhere, sometimes a little more recklessly than we would like here.
Yeah. Do we need embryonic stem cells to do what we need to do? Can we?
Well, we now have that new type of cell where we don't need embryos and where we do not need to destroy embryos. In fact, I published a paper back, the last decade where we actually showed we can now create those cells without destroying the embryo. So we're actually right now in the process of making new master banks for our clinical trials where no embryos were destroyed. So I think between that new technique, which doesn't destroy the embryo, versus the iPS cells, I think we're moving ahead where there shouldn't be any controversy.
Absolutely. Should be phenomenal. I don't hear much about cloning anymore, Robert. How come?
Well, actually, this iPS cell technology is one of the main reasons. It turns out that what has happened is that the goal of cloning wasn't to make, 100 copies of, George Zimmerman or Mitt Romney. What we were trying to do was actually make these cells, stem cells that were immune compatible. So say you have heart disease, we can't just make you cells and plunk them into your body because your body will reject them. You need to have your own cells to prevent that.
Right.
And so these new iPS cells, I can just take a blood sample from you or some skin and actually do the same thing that we were wanting to use cloning for. So we don't need cloning anymore to do that.
Okay. That's fascinating. Gosh, what a great science.
Oh, thank
Truly
you.
is. The amazing times ahead.
It is, and I think within our lifetime, one day you'll get in an accident and lose your kidney, and you'll just go to the doctor, and he'll take some skin cells and grow you up a new kidney. Yeah,
and it's done. Well, they're doing that with ears now and stuff, aren't they?
Exactly. We can now, grow up all types of tissues. Tony Atala, who we've worked with on making tissue engineering and growing up miniature kidneys, has also made bladders that are now being used in patients. So we're now making vessels and ears, and you can virtually, all the tissues of the body, we're now learning to reconstruct and hopefully, like I said, one day we'll just be able to grow you up whatever organ you need.
If you need a new nose, you just get it done.
Right. What you do is you have this synthetic scaffold, and you seed the cells onto it, and then they grow, and eventually, once you transplant that back onto the patient, the synthetic material is reabsorbed, and you're only left with the living tissue.
Boy, that'll change plastic surgery. If you want a nose that looks like someone, they just give you the mold, and you put your own cells on it, and there you go. We're going to be back in a moment. Robert Lanza, our special guest, as we talk about biocentrism next on Coast to Coast AM. Yes, you are, with our guest tonight, Robert Lanza, as we talk about biocentrism, and we're going to get right into that, cosmology, next on Coast to Coast AM. And welcome back to Coast. Our guest tonight, Robert Lanza. We're talking about his latest work, Biocentrism. Robert, comes with a little controversy. We'll get into that. Some scientists say, hey, I don't know about this theory, but let's get into it. In your view, what is biocentrism?
Well, it's a new theory of the universe, a completely new view of the world. So we think life is just a big accident, but a long list of experiments suggest completely the opposite. So amazingly, if you add life and consciousness to the equation, you can explain some of the biggest puzzles of science. So, for instance, it becomes clear why space and time, and even the very properties of matter itself, depend on the observer. And biocentrism also explains why all the laws, forces, and constants of the universe are exactly fine-tuned for the existence of life. So it turns out that life and consciousness are the keys to truly understanding the nature of the universe.
What came first, the life in the consciousness or the formation of the universe?
See, so that's exactly the dilemma we're in because of the existing paradigm.
Yeah.
What that assumes is that there's this matrix out there called time that's just ticking away. And everyone knows that you know, if you say, okay, what came first, this or that, you're assuming there's just something out there that came first. But everyone knows there's something strange about time and space as well. They're not objects like the shells and pebbles we pick up along the seashore. So if you wave your hand through the air and you take everything away, what's left? And the answer, of course, is nothing. And so we think of space as a vast container without walls, but that's wrong. We know from Einstein's relativity theory, for instance, that the distance between objects changes depending on gravity and velocity. So there's no absolute distance between anything and anything else. And the same thing applies for time. You can't put it in a bottle like milk. In fact, quantum theory casts doubt on whether things are truly separated in space and time at all. So, for instance, there are these things known as entangled particles, which act in unison as if they were, even if they were separated by the distance or width of the galaxy, it doesn't matter. They act instantaneously as if there's no space or time between them. So, if you look at anything, say the radio you're listening to, if you can't really see it through the bones surrounding your brain. Everything you see and experience right now is a whirl of information occurring in your mind. So space and time are simply the tools the mind uses for putting it all together.
All right, let's. This is going to get fun. Let's talk about the chicken and egg for a moment.
Okay.
Because that'll be kind of interesting as we get into this.
Okay.
So you need a chicken. You need a female chicken, and you need a rooster to fertilize the egg, and then a little chicken pops out. Mm-hmm. So you need a female chicken to lay that egg. Mm-hmm. So in the scheme of things, in order to get that egg, how did we get the female chicken first?
So this is exactly how the human mind is structured to think. We think
logically, right?
Yeah. Well,
or chronologically.
Well, we think linear. That time is like an arrow, and you know, you're young and you get old, you die, and you know, and everything ticks along. And then that is because that is how consciousness works. Space and time are the tools, the language of consciousness. But when we start to do all these experiments, we start to figure out, well, wait a minute, there are cause-effect connections, and these experiments are showing them that do not operate using the normal classical way of thinking. So when you think of the chicken and the egg, you're just thinking. So the way I like to think of it is like, you know, you see a squirrel outside and he grabs the acorn and he runs up the tree and doesn't think anything about it. He just opens his eye in the morning and the world is there. And we're very much like that squirrel. We open our eyes and we think we're just here magically, and that the universe is here with all the laws, forces, and constants exactly right for us, and just a big accident. And that's the mistake. So when you think of the chicken and the egg, what all human thinking is relational. So you can't have darkness without knowing what brightness is. You can't know, order is probably just the other end of the circle of chaos. So all of these things, the beginning and the end, it's part of a system of logic. So what the mind does is it processes information. It's an information system, very much like the material on your CDs when you watch a movie.
I asked a blind person once, what is red? What is blue? What is black? And, it's interesting because they have shaped their own mind, in their own mind, what the colors are.
Exactly.
Yet for us, we've got to see it in order to know it. I mean, if I tell you I've got a red phone on my desk, you know exactly what it looks like.
And you hit the head of the nail right on. Consider the weather outside. You see a blue sky, but the cells in your brain could be easily changed so the sky looks green or purple. And in fact, with a little genetic engineering, I could probably make everything that's red vibrate or make a noise or even cause pain or make you want to have sex like some birds do. So we think it's bright outside, but your brain circuits could be changed so it looks dark. You think it's hot and humid, but to a tropical frog, it would probably feel cold and dry. So that logic applies to virtually everything. So bottom line is everything you see out there, the reds, the colors, sound, it requires your consciousness. And again, you can't see those things out there through the bone that surrounds your brain. This is all the way your mind is processing this. And even blind people, that's an interesting thing there, too. I mean, in medical school, I always remember that there were some patients, for instance, that were blind, and if you had a pole in front of them, as they approach it, they would duck and go under it, even though they couldn't see it.
Yeah.
So it's a very complex way the mind works.
Well, there's no doubt that whatever has happened here in the universe is not an accident. I mean, I argue with people day in and day out, those who believe that the universe merely just did all this. It just, everything just clicked. There's too much order to it.
Yeah, you're absolutely right. As a matter of fact, it turns out that the universe has a long list of traits that make it look as though everything was exactly tailored just for us. And some astrophysicists are calling this the Goldilocks universe. In the old nursery tale, Goldilocks enters the home of three bears, and she tries different bowls of porridge. Some are too hot, some are too cold. And every time she tries the beds and the chairs, everything, the third one is always just right. Well, it turns out that the cosmos is exactly the same. Everything is just right for life, not to this or to that. So you can claim it's all a big accident, but right starting from the Big Bang, everything seems to have been just incredibly lucky. So, for instance, it started at the moment of creation. When the Big Bang exploded, if it had been one part in a million more powerful, the cosmos would have rushed out too fast for stars and worlds to form. Result, no us. Or if gravity or the gravitational force were decreased by a hair, stars, including the sun, wouldn't have ignited. And there are over 200 parameters like that could have any value at all, but happen to have exactly the right value for us to be here. And it strains reason to think that they're completely random. You tweak any of them and you never existed. So claiming it's all this big dumb accident is no more helpful than saying God did it.
Bingo. Well, it is something that baffles the mind. I have always said there are no coincidences, that these things happen for a reason, that there's a design here. We'll talk about God a little bit later because I want to get your views on that. But let's talk then. Let's bring in your views of this biocentrism, which basically this is your theory, isn't it?
Yes, this is correct.
And have you come under fire from some colleagues?
Yes, as a matter of fact. You have to remember that this is an out-and-out challenge to physics, indeed a whole view of the world. So it's not surprising that some people are going to get defensive, indeed quite nasty about it. And, you have to remember that most of us have had more years of indoctrination in school than monks get at monasteries. And so it's far worse for anyone who has had decades of intensive scientific training. And trying to undo a worldview is almost impossible. It's like trying to get a dog to roll over when you tell it to sit. And, but that being said, I've gotten dozens of emails from people, even professors, chairmen of the scientific departments at Johns Hopkins, Columbia, Florida, as well as biologists, and they say, you're right on. So the main problem occurs because biocentrism is a proposal for a paradigm shift. And by definition, a new paradigm always appears to be nonsense from within the established paradigm. But that's what science is all about, to carry out experiments and to figure out what's really going on. But scientists are human beings, too, and they have prejudices and preconceptions just like all of us.
Well, why can't humankind, though, Robert, accept honest debate, whether they agree with you or not, without going crazy, without getting ballistic about it? It's almost like, the global warming people, and, I happen to believe that Earth is a cycle. It's been warm before. It'll be warm again. Hundreds of thousands of years ago, we had higher carbon dioxide during the dinosaur era. I believe that doesn't mean I'm in favor of pollution by any means. I think we need a clean planet. But rather than debate and for people to sit back and go, well, all right, you're right. The Earth was much warmer 100,000 years ago. They attack you and they scream at you.
Yeah. Well, people definitely have their own self-interest. So, for instance, if you tell a physicist that his life's work was a joke and that he shouldn't be applying for grants because that's a waste of time, he's not going to be happy.
No, but I guess there's a way to say his life was a joke without saying it like that, right?
Yeah, that's right. But on the other hand, if the scientific consensus should shift, who gets grants and who doesn't will also shift.
Well, that's true. And it's all about grants, isn't it?
Well, no, that's one part of it, but clearly one of the problems is it's even Einstein, when he came up with relativity, that was cutting edge at the time, but then along comes quantum theory, and all the new physicists came along and accepted it, but Einstein didn't, and his famous line, God doesn't play dice. It turns out that it's very hard once you've grown up as an adult and been bombarded with certain ways of thinking to undo it. I don't know who it was that used to say the only way you're going to really change is one funeral at a time. Is that it's the same thing, for instance, for gay marriage. If you look at the polls, all the young people are very much in favor of it, and as you get older and older, us older people are more resistant, and the support drops off very dramatically. So I think that's true of any new way of thinking.
Well, that's true. Absolutely. So in 2007, you come up with the biocentric universe theory, which basically says, I'm going to paraphrase you, that life creates the universe rather than the other way around. Is that pretty accurate?
Correct, yes.
Okay. So we will digest how that is. Give me your thoughts on the Big Bang. What was it?
So the whole thing of the Big Bang and the whole thing of the universe is what's going on. And so I think the whole thing is an enormous oversimplification. And so I think when you think of the Big Bang, you're thinking of one of the formative events in the universe. So, for instance, right now you're talking to me, you're sitting on a chair that's going around, it's on the Earth rotating around the sun, and that's in the Milky Way going around. And all that, if you go to the extreme, you come to the edge of the known universe. Likewise, if you go back, your body is made of carbon. Carbon is made in exploding supernova stars. And if you take that logic all the way back to its extreme, you come back to a singularity, to the Big Bang. So the Big Bang, as well as the universe, is basically the spatial temporal logic of consciousness, of you, of the observer. And this is exactly what all the experiments are finding. Einstein showed, that space and time are relative to the observer. We're now finding, experiment after experiment, that the very properties of matter, its location in space, its temporal properties, are all relative to the observer. And people say, well, that can't be right. How can what's going on out there be dependent on what you think or what you feel? And so you now have the scientific world fractionated. You got one theory that explains quantum theory, and then another one that's completely almost opposed that explains space and time, and they cannot be reconciled, even with these brilliant people such as Stephen Hawking, who by the way, has a new cosmology, a top-down cosmology, saying that what happens in the present determines the past all the way back to the Big Bang.
I have had such a difficult time comprehending the Big Bang Theory. When they say that whatever this is started from a very minute point.
Yeah.
I just can't.
It's magic. One day, suddenly, out of nowhere, out of nothing, you get, 100 gazillion tons of matter. and all the laws of nature out of nowhere from nothing. Once upon a time in biology, they had something known as spontaneous generation, and they used to think that mice came from old clothes, or flies, came from decaying meat.
Yeah.
And we learned that it doesn't work like that.
I have an easier time thinking that an object the size of the universe blew up in all these pieces are what's out in the universe right now. I would believe that more than the Big Bang Theory.
Yeah, well, again, I think that more and more we're coming to believe that what we think of as the Big Bang is just part of an endless process, that the universe is eternal, whether, it's the big crunch and the big expansion. But I think, again, what we're finding more and more is that the world doesn't go together the way we think it does. You can extrapolate the logic, very much like, when you were in geography class and they had that world globe, and, that was, in theory, what everything is possible on the Earth, but you know perfectly well that, you can't go to Antarctica, under most conditions that is pretty extreme. And so I think the universe is really, again, the exhaustive logic that explains any event that is occurring, which is why virtually everything appears to be observer-determined.
Now, because you're a scientist, I'm sure you've experimented and you've used methods to try to back up your theory. Have you, and what have they been?
Well, as a scientist, I've been accumulating pretty much all of the experiments that have ever been done. So there are new ones that I think are pretty dramatic. For instance, one of the most famous ones is known as the two-hole experiment. So when a scientist watches a particle pass through two holes in a barrier, the particle behaves like it should, like a little bullet, and it goes through one hole or the other. Now, the catch is that if you don't watch it, it acts like a wave. It can go through both holes at the same time. So how can a particle out there change its behavior depending on whether or not you watch it? And the answer is simple. Reality is a process that involves our consciousness. It's not a thing. There's another famous axiom in science, Heisenberg's uncertainty principle. If there was really a world out there with particles just bouncing around, then we should be able to measure all the properties. And it turns out you can't. So, for instance, a particle's exact location and its momentum can't be known at the same time. So why should it matter to a particle of matter what you decide to measure? Again, the answer is simple. The particles aren't just out there. Or more recently, these particles known as entangled particles. How can a particle possibly instantaneously be connected on opposite sides of the galaxy? This violates Einstein's relativity. So they behave as if there's no space or time between them. So again, all of this is because space and time are not external objects. They're tools of our mind.
All right. The fact that you have literally turned this upside down from what conventional science and physics has always believed with this thought now, what does that tell you? What does that tell you about just the thought of these scientists and physicists prior to what you came up with?
Well, the funny thing is a great scientist at the turn of the century, the last century, famously said that, all previous generations have lived and died in a world of illusions. And the irony in that comment was that that was before Einstein and radioactivity, before quantum theory. So this is exactly it. If you imagined 100 years ago, and I pointed up to the sky, and there was this little speck of light up there, and I said to you, oh, there's 500 people up there whizzing to China eating peanuts. You'd think I was nuts. And that was just 100 years ago. So that just shows you, how primitive our thinking may be today compared to what's really out there.
You've come up with your thought about if a tree falls in the forest, if there's nobody there, does it make a sound?
Right.
What about this, too?
Well,
if, for example, a tsunami hits an island and kills 300,000 people, but if we never see it, if we never go there in our minds, has it even happened?
Well, that's a very complex, what I would call intersubjective question. So the answer is yes and no. Of course, there were people who were there, and they would talk to people, and so all of those cause and effects have to follow. So you have to follow causality. But when people say, like, for instance, does the tree make a sound when it falls? It's really a question that many people say, well, of course it makes a sound. It's too dumb to even consider thinking about.
Right.
But what you're really doing is taking a stance. You're saying that you believe in an objective, independent reality. And that's the prevailing mindset, the Western view held since biblical times. The little me is of small importance in the universe. But what really happens when a tree falls? So basic science says that sound is created by a disturbance in the air. So when the branches hit the ground, they create these little pulses of air. And what you have are these little air pressure variations, which spread out at 750 miles an hour. So according to that view of science, what occurs even when an eardrum is absent are just little puffs of wind. There's no sound at all attached to them. Now, if a person listens and it vibrates the eardrum, only if it's pulsating between 20 and 20,000 times a second will you get noise.
Now you brought up something very fascinating. We'll talk about that when we come right back. With our special guest tonight, Dr. Robert Lanza, as we talk about biocentrism, cosmology, and we'll be back with him in a moment on Coast to Coast AM. Robert Lanza with us. Robert, let's go back to the tree falling in the forest, nobody there, and you're saying that you need, obviously, an ear to pick up those vibrations, right?
Exactly.
What though, if we put a tape recorder there and left, would that tape recorder pick up that sound?
Okay, so there's several components to that. One is, bottom line, biologically speaking, is that any sound, whether it's from the tree or you're recording, it's going to vibrate a certain number of pulses. So, for instance, there's intrinsically no difference between sound that's vibrating, say, 15 times a second and one that pulses at 30 times a second. Yet the former will never result in human perception of sound. So the ear and brain are every bit as necessary, whether it's a recording or the tree falling, for the perception of sound. So again, the external world and consciousness are correlative. So that when someone answers dismissively, of course the tree makes a sound when no one's nearby, they're merely demonstrating their inability to ponder an event that no one attended. They're finding it too difficult to take themselves out of the equation and to imagine. And the other thing is we know for a fact that without an observer, not a single particle in the tree or your tape recorder exists with definite particles until it's observed. So until it observes, there's only waves of probability. This is what physicists have been studying now in the whole area of quantum mechanics. Without consciousness, nothing remotely resembling the tree could exist. In fact, John Wheeler, who was Einstein's colleague, he's actually the great physicist who coined the words wormhole and black hole, once said, no phenomena is a real phenomena until it's an observed phenomena. And he's exactly right.
Is this like Schrodinger's cat, that experiment?
Exactly. But again, if we do any experiment and we measure any particle whatsoever, whether it's an electron or a proton or whatever, it turns out that it has no properties until you actually observe it. And again, the same for space and time, that we carry them around very much like, turtles with their shells. So, I mean, I could go through 100 different experiments to give you an idea of what's going on, but it is very much like Schrodinger's cat in that all the great physicists today, even, like I said, Stephen Hawking and others, realize that waves, that particles only exist as a what we call a probability wave, and it's the observer that collapses it or that gives it its definite properties.
Your theory of biocentrism is based on 7 principles, right? Let's go through each one, digest each one, if you would.
Okay.
Principle number 1, what is that?
Actually, I don't have it in front of me.
I do.
That was a summary that the editor asked us to put at the end.
I've got it, so I'll read it and you can comment on it then. Okay. I'm playing the part of the scientist at this point. But what we perceive as a reality is a process that involves our consciousness. And external reality, if it existed, would be by definition have to exist in space. This is meaningless because space and time are not absolute realities, but rather tools of the human and animal mind. What does that all mean?
So we discussed a little about that, about color, that color is completely subjective, that And the same thing applies to virtually all of the properties. So what is going on is, again, everything you are processing and experiencing right now is going on in your head. So, for instance, if you dream, you're able to recreate space and time. You're able to fly and move. You're actually able to come up with that sensation and feel things, even though it's all in your mind. Your mind puts things together using space and time as tools. And this is exactly what one of the greatest philosophers who ever existed said. Immanuel Kant, over 200 years ago, said almost exactly the same thing, that space and time are concepts of the mind. These are the way we put everything together.
Okay, the next one, our external and internal perceptions are intertwined. They are different sides of the same coin. They cannot be divorced from one another.
So what we have now are experiments that show exactly that. Again, I had mentioned one, for instance, the two-hole experiment, that if you look at it, it's a little bullet. It behaves a certain way. If you don't look at it, it doesn't exist. It has no property. It's what we call a statistical wave of probability. So it has no existence if the observer isn't involved with that, and it goes through both holes if it's not observed. And the same thing goes on for Heisenberg's uncertainty principle, is if you measure one thing, it's sort of like the man and the woman in the weather vane. If one goes in, the other one comes out, and it depends on what it is exactly that you're observing. So experiment after experiment shows that your internal and external perceptions are intertwined. Whether you observe it or don't observe it makes all the difference in the world.
The behavior of some atomic particles, all particles and objects, linked to the presence of an observer. Now, that's what you were saying. Without the presence of a conscious observer, they are best existing in an undetermined state of probability.
And this is exactly right. As a matter of fact, I had mentioned John Wheeler, and just before he died, he actually said that if you observe light from a distant quasar, we're actually setting up a quantum observation on an enormous scale. And that means that the measurements that we are actually making right now determine the path it took billions of years ago. So again, this is what we're finding even at the microscopic level with these particles, is that they basically are just statistical projections, uncertainty, until they're actually observed.
Next one, of course. Without consciousness, matter dwells in an undetermined state of probability. Any universe that could have preceded consciousness only existed in a probability state.
So again, what we're finding is that when you study atomic matter at its lowest level, that it has no properties until it's actually observed. So its actual location in space and its position in time are not observed until you actually observe them.
The universe is fine-tuned for life. Makes perfect sense, as life creates the universe, not the other way around. The universe is simply the complete temporal logic of the self.
And this goes back to the big question you had about the Big Bang. How did all the laws of nature and everything just suddenly appear like magic and pop into existence one day? And they didn't. So it's because what we're seeing in terms of the universe is a reflection of the self. Time
is the process by which we perceive changes in the universe.
So again, time is the way it's animated. So if you think of a movie or a film and you have the still shots, what happens is the way they're woven together, that is what the mind does. It weaves these spatial states together.
Space, like time, is not an object or a thing. It's a form of our animal understanding and does not have any independent reality. We carry space and time around with us like turtles with shells. Thus, there's no absolute self-existing matrix in which physical events occur.
So this is, again, comes back to everything that Einstein was saying about space being relative, is that it turns out that my measurement of how far Disney World would be from my house would be completely different than another observer who may be traveling at a different speed, so that there's no absolute distance that is between any object and any other object, and this has been verified over and over, by hundreds of experiments.
Assuming your theory is correct, what does that mean? What does that mean to us?
Well, everything. I mean, right down to the most basic life and death. I mean, right now, one of the biggest fears almost every person who's alive has is they die or their significant other or child has died and left, and it's traumatic. I mean, people just that's probably the biggest question that exists. And I think that this basically says, hey, whoa, wait a minute, that's a silly idea. Again, that assumes this invisible matrix out there that we call time. We think we die and rot into the ground, but these experiments are suggesting that this view is wrong. Again, as I mentioned, that space and time aren't objects, the way the mind puts it all together. So, for instance, just to give you an example, quantum physics right now, one of the mainstream explanations is that it's called the many-world interpretation. So this states that there are an infinite number of universes, the multiverse, and so that anything that could possibly happen that occur in one universe could happen. In other words, could happen in any of those universes. So death doesn't exist in any real sense in those scenarios. All the possible universes exist simultaneously, regardless of what happens in any one of them. So biocentrism extends this idea, and it suggests that life is an adventure that transcends our ordinary linear way of thinking. So although our bodies self-destruct, the me feeling is just energy operating in our mind. So this energy doesn't go away at death. One of the surest principles in science is that energy never dies. It can neither be created nor destroyed. So when someone dies, we do so not in this random billiard ball matrix, but in the inescapable life matrix. So life has a nonlinear dimensionality that transcends any individual history or universe. It's like a flower that returns to bloom in the multiverse. And so again, I think that biocentrism has impact not only on issues of life and death, but also virtually of everything we're trying to do in science, and that is to understand how the world is put together, why it's here, and what it's all about. And so I think we're on the wrong track here, trying to just assume there's this thing out there that just popped into existence one day.
Are we in an illusion? Is this even here?
So this again is it always goes back to Socrates once said define your terms. So I think that you can say okay space and time illusions, and I think that the question is that obviously I am, therefore, you think, therefore you exist. So something is happening. The question is how do you define that? So if you define space and time as things, well, it isn't all an illusion. But if you say, okay, they're just the tools that we use to understand things, well, of course, we're experiencing things. That is very real. So I think what we need to be very clear of are the terms and what we're saying are real or not real. Think of it as you knock on the table, okay, and you feel it. It's hard and it's solid, and you say, well, is that an illusion? Well, okay, you knock on the wood and or a rock and it's hard, but on the other hand, science now knows that that's almost entirely empty space. It's as empty as a fly being in the middle of a football field, and we know that it's not only not solid, but it's not inert like we think it is. It's particles whirling around billions or trillions of times a second. So it depends on at what level you're asking the question. So yes, you can say that the table is solid, but science knows for a fact that it's mostly empty. So what's right in one set of circumstances is wrong. So we're really tied to the use of language and words, which often carry a lot of baggage that can infer something that isn't correct.
Where does God, if anywhere, fit into this equation?
Well, God. First of all, God is a big word. It's bigger than anyone can comprehend. And personally, I don't take a position, about whether there's this wrathful God that drowns people like in Noah's Ark. But I do believe there's more to nature than science acknowledges. And I also think that biocentrism makes a convincing case that there's absolute justice. So in the most meaningful sense of the word, I think, yes, there is a God as best we human beings can wrap our mind around that concept.
All right, let's talk in terms of what we're doing here. I mean, I think one of the biggest questions, Robert, when we ask that, who are we? Why are we here? What's going on? Those who are religious will say that, we're here to perfect ourselves, to perfect our souls and go off to heaven or hell. Those who do not believe in that, and there are many out there who don't, would say something else. But the big question is we walk around as human beings. You're on this radio show. I host it every night. What are we doing here?
Mm-hmm.
What is it all about?
Mm-hmm. do you want a one-sentence answer? No. The truth of the matter is, even biocentrism, as hard as it may be to wrap your mind around, I would always call that reality 101. Again, we're very primitive creatures. We evolved in the forest roof to collect fruit and berries, not to ponder the universe. So that when we talk about God and religions and people talk about why are we here and all of this, a lot of this has to do with what I had mentioned earlier about knowledge being relational, so that there are truths in almost all of these religions. There are truths in much of science as well. And I think where you go wrong is that when one part of your knowledge contradicts another. So I think that almost everyone as a human being has a sense of what's going on. We live, every day in our lives, and we experience people dying and things happening. So I think we know. I once said, that life is the meaning is in the lyrics of the song, and everyone knows what's meaningful in their life, whether it's their children or their work or what they're doing. And I think where we get into trouble is that when we try to extrapolate that. And we can make lots of mistakes.
Well, maybe so. But, isn't there some kind of intelligence behind this?
Well, I think there's a lot more intelligence going on than anyone has any idea. I think that, even when we talk about our universe and space and time, that's just one information system. Surely there are other information systems that we're not even capable of understanding because we think in terms of space and time. All you got to do is alter those algorithms, and you could walk through the multiverse like we walk through the room. So I think we're so primitive that we can't even begin to comprehend what's out there.
Well, that might be.
Might be, yeah.
Physicists, what do they say about this? What theories do they come up with in terms of life? Is it just an accident?
Yeah, I think physicists, basically everything breaks down to the laws of physics and chemistry. We're just simply a bunch of atoms. We're a little bit of debris circulating around the edge of the Milky Way galaxy, nothing more. That's it. That's what it is. And of course, it's a nice, convenient little theory. Is that all you do is plug in this equation and you have the answer. But this is foolish because what's happening now is they're sweeping experiment after experiment under the rug. They can't even explain. As you mentioned, why did the Big Bang, everything just come out of nothing? What happened the Tuesday before that? There are big questions that explanation just is almost idiotic. So again, the question becomes, why do we observe these phenomena that we do, say, in the quantum world, or the two-hole experiment, quantum entanglement? And I know the physicists like conveniently to get out of that by saying, it only works in the small world. There's actually two worlds out there, one set of laws for small objects, that's their quantum theory, and then the other is for relativity, which is for the rest of the universe, including us. But there's no basis and reason for that, and it's being challenged in laboratories around the world. So even just last year, researchers published a paper in Nature showing that this quantum behavior extends into the everyday realm. So, for instance, they had these vibrating ions that remain bound together even when separated by huge distances, which is what Einstein called spooky action at a distance. And there are other experiments with these huge molecules called buckyballs that show that this quantum reality extends beyond the microscopic world. And in fact, in 2005, these crystals that scientists studied exhibited these entanglement ridges half an inch high, quantum behavior in the ordinary human scale of things. So where did the laws of physics change, between, an inch and 2 inches or 4 inches? It's crazy. So I think this is a problem with the way physicists are looking at the world today.
Are we alone in the universe?
No. Again, you could answer that both ways, but I think that clearly there are an infinite number of information systems, entities, and realities. And we're not alone in that sense. But, in terms of space and time, we're all connected. But that's a whole different story.
Do you think more scientists are beginning to accept this theory of biocentrism?
Yeah, I think you're seeing more and more people. I think we're in the middle of a change in worldview. These things take time. And, I can't remember the exact, I think it was Arthur Schlesinger once said that I guess there are three forms that all truth goes through. First is that it's ridiculed. The first one is I think it's dismissed outright. Then it's ridiculed. Then let me correct this. First, it's violently opposed. Second phase is that it's ridiculed, and then the third phase is it's accepted as self-evident. So I think we're going through that. We're now at the point of the ridicule, and I think that probably in 5, 10, maybe 20 years, I think you're going to see a major shift in the way society views.
Let's talk about time, Robert, when we come back on Coast to Coast AM. Well, next hour with Robert Lanza, we'll take your questions. You become part of the program. We'll be back in a moment with them on Coast to Coast AM. Robert, let's talk a little bit about time. It seems to me to be clicking pretty darn fast. But again, is this an illusion?
Well, actually, there was an experiment that was published in the prestigious journal Science a couple years ago. Scientists in France sent particles into a measuring apparatus, and they showed that what they did now in the present could retroactively change something that had already happened in the past. So as these particles passed the fork in the apparatus, they had to decide whether to behave like particles or waves when they hit this beam splitter. So later on, well after the particle had already passed that fork, the experimenter could turn the switch on or off. And it turns out that what the observer decided at that point determined what the particle actually did at the fork in the past. At that moment, the experimenter chose his past. And of course, we live in that same world.
Well, we do live in that same world. What did Einstein say about time?
He said that past, present, and future is a stubbornly persistent illusion. So I have to agree 100% with that.
What about deja vu? Where does that fit into this?
That may be more complicated, and that's probably beyond my area of expertise. Okay. But I'm open.
but it does tell you that there are constantly strange things happening.
There are, and we certainly know in these experiments there are a lot of strange things that are happening.
Did you touch upon other dimensions?
Well, one of the things is that, we think that our destiny is the journey to Mars and beyond. But sometime in the future, I think science is going to be able to create realities, other dimensions that we can't even begin to imagine. So, for instance, we'll be able to construct other information systems or universes based on logic completely different than ours and not based on space and time. So at present, we live and die in the everyday world of up and down. But if, for example, I think I had mentioned this earlier, is that if we change those algorithms, that instead of time being linear, it could be 3D like space. And so consciousness would move through the multiverse and, again, would be able to walk through time just like we walk through space. And so after creeping along for 4 billion years, we'll finally figure out how to escape from our corporeal cage.
As you continue to evolve with this, I mean, where else could this take you? Or what else is out there on the horizon?
Well, there's a lot. The problem I'm having right now is that because just even explaining the basics of the fact, if I were to say to someone, hey, what you see out there you can't see, even that's a hard concept, to say, well, what you're seeing right now is constructed in your head because you can't see that. Once you can get past that, then I could go the next step and start telling people things that, all the great philosophers for millennia have been saying, the Buddha and everyone, that it's not just poetic wording when we say that we're all connected. I mean, I think a more advanced society downstream would evolve as a result of this. When we start to realize that space and time, these walls that are we believe are between us, that they're illusions. Explain
a little bit more about that.
So I think it was Emerson, Ralph Waldo Emerson had said that, to think of space and time as solid walls is a sign of insanity. And so basically by thinking of space and time as objects that are out there, we just think that, if we were to, punch someone and they were to bleed, well, that's their problem. Well, it really isn't. It's just that we think we only can experience time piece by piece. So, you think of time like one of those old vinyl records, you can think of every like the songs before as being the past, and the songs in the future, that you would listen to after your song as being the future. And the thing is that the record always exists regardless of whether you're listening to this or that song. So I think when it comes down to space and time, I think that your consciousness that you were when you were a kid is also behind who you are right now, but it's also behind all the minds of all animals and all people. And that's a very hard concept for us to understand. And I think in the past, many philosophers, have tried to express that poetically. But I think we're getting to the point where as our science evolves, we may be able to explain it in a more concrete way. Let's talk, if we can, about the illusion of death. You touched on this somewhat. Mm-hmm. But we do physically die, right? Yes, this is definitely true that we know our bodies die. All right. So if we know our bodies die, mm-hmm. do you believe in a soul? Well, yes. I think that, again, what's going on here is that we don't realize that the world itself, the universe, is a process. Again, it's a correlative process. So all matter, all particles, everything that's happened is relative to the observer. And I had just described to you the experiment that was carried out in science. And so the question is that you flip the switch and you determine the outcome, whether what happened in the past. So you, again, as Stephen Hawking says, this is the top-down cosmology. And if you think about this in terms of time, it only makes sense that until you collapse the present, how can you have a past? So I guess the real question when it comes to death is does that energy that that your mind uses transcend from one world to the other? And so I think regardless of the choice you, the observer, make, it will be you who experiences the outcome. And so you do transcend the death of your body. And I think it was I'm just trying to think Spinoza who said that there is a part of the mind that survives the death of the body. And so what happens is that these various linkages between the histories and universes transcends our ordinary classical way of thinking of space and time. So you can think of your mind as being 20 watts of energy, and as that energy is simply hollow projecting either this or that result onto the screen. So whether you turn the second beam splitter on or off in that science experiment, it'll still be the same battery or the same agent responsible for that projection. All right, let's talk about consciousness and how it fits into this equation. You believe it's critical. It's critical to make this entire theory work, right? Well, I think that the consciousness is the language of reality. Okay. So by that I mean space and time are the tools of the mind. That is the language by which we experience existence. That is how the world was put together. So without that, there's nothing. And that's exactly what the experiments are showing, that when the observer doesn't observe those particles, they're not there. Robert, I have on Friday what I call a prayer moment for people to use their consciousness for people who are sick. Okay. And people write in, my Aunt Emma, she's got this problem, da-da-da-da-da. And then people just concentrate on this list on any given Friday. Mm-hmm. It seems to work. Mm-hmm. I can say that now after doing this for several years. Mm-hmm. It seems to work. The question is how and why. How does prayer, consciousness, change things, alter events? Well, that is a very big issue that you're dealing with, and there's no simple answer other than that we do know for a fact that there are many possible outcomes to any event, and that only when you are aware of it, that when you observe it, do those possibilities collapse to one outcome. Again, though, as a scientist, I'm a little bit old-fashioned on some of that in that I think that, you can't violate the laws of physical causality, but within that range is a lot of space. Do you believe that time travel one day will be possible? Oh, yeah, absolutely. I don't think there's any question about that. I think that, again, someone once said to me, well, Bob, you're crazy. If you're saying there's no such thing as time, how can there be time travel? I think, again, space and time are algorithms. They're the way the mind puts things together. Again, I had mentioned that, even when you dream, even though your eyes are closed, you're able to move in time. You're able to fly in space. Your mind puts those realities together. And so, again, by tinkering with those information systems, I think essentially you can create and go back or forward if you had the ability sometime in the future to modify those algorithms.
Well, that's
and I think it will be possible. But the time travel, the way I would propose it, even though it would be very real, would operate in a completely different way than many of the movies that you're seeing.
When you began to come up with your theory on biocentrism,
mm-hmm.
did it hit you like a brick, or was this something that took a long time to develop?
Well, one of the things is this started when I was very, very young. I'd turn over stones and, I'd find snakes and salamanders, and I'd reach into holes and catch owls and squirrels. And I started realizing that, they have their own world, their own universe, their own way of thinking of things. And as I went to school and started learning about science, there was a disconnect. And so I knew, just like you and many other human beings know, that there's something terribly wrong with the way we're looking at the universe. I mean, it doesn't take a genius to realize, as you're saying, that, the Big Bang, didn't just come here, why are we here? There's these big questions that science doesn't have a clue, no idea.
No.
And they're dead wrong on many of these things. So when I went to science class, someone once said to me, it's dangerous to read about something until you've thought about it yourself. So I started putting things together. I had a hunch how they worked. And as I went through science, I started incorporating more and more of what I learned in the books in my view of the world. And it then became clearer and clearer as I went, when I was at the University of Pennsylvania taking advanced physics. I remember the very first exam, I think the class mean was 30. And, I think when they finished their bell curve, I had 101. And as much as I could do great on these tests, it became a serious problem, and I couldn't follow through with it because they were making me just basically swallow just incredible amounts of information in a way that was wrong, that could never be undone. And so I had to pull out and learn it slowly and reprocess that my own way. Because once, for instance, one of my colleagues was a 14-year-old kid that had just finished his PhD program. He had just crammed every piece of knowledge into his head. There'd be no way for him to ever go back and undo the damage that was done. Once those connections are made that way, you don't know how it all went together. So for me, it was something that evolved. The more science I built, I incorporated into it. Because when you deal with a new paradigm, a new shift in viewpoint, you can trip very easily, and you can come up with all sorts of imagined refutations. Sort of like, well, if I don't look at the moon, it's not there. Well, what about if someone else looks at it? Or, and of course, all of that is completely right. No one is saying that what you observe and what we know to be true isn't true. It's just, how does it all go together in reality? And that's what, hopefully this will help explain.
Why do some physicists, though, think that your theory is wrong?
Again, I think it all comes back to, I once talked to a physicist about this, and I said to him, okay, he said to me, Bob, he says, if you came to me with 10 pages of experiments that proved Einstein was absolutely wrong, even if you were right, I wouldn't believe it. He's God. They were trained that way, to think that way, and unfortunately, it's almost impossible once someone is that heavily indoctrinated to just totally, throw away everything they ever learned. It's almost impossible to undo that in your mind, because you've got every connection made a certain way, and you wouldn't even know how to go back and undo those connections.
So, but they do argue about, they're very reluctant to give in, aren't they?
Well, right. They're happy to discuss scientific viewpoints within the existing worldview. So Einstein, for instance, was operating within the existing worldview. His theory of special relativity and general relativity basically was just a modification of, to a large extent of the old Newtonian worldview. What I'm proposing here is basically, that the reason we've reached this roadblock is that approach is wrong, and even many Nobel laureate physicists are saying that there's a problem with consciousness, that we cannot derive it from physical laws. And many people will get the issue confused, and they'll think, okay, believe me, I studied neuroscience. I worked with, Kufler, who was the founder, of all of neurobiology. But what neuroscience is showing you is how certain parts of the brain process information. And that, yes, we can figure that out. We can figure out those mechanisms. But that doesn't explain why you have an experience to begin with, how you have a subjective experience. How do you think and feel you are you, and how do you, smell a rose or see the beauty of the sunset? All those are subjective feelings. That how does consciousness exist in the circuitry of the brain, and there's no answer. And this isn't a small question. This gets right to the heart of all the basic problems in physics. All of the problems that they are assigning to space and time as physical entities is where the problem is occurring. They're overstepping the legitimate boundaries of science. They start to assign physical properties to these non-entities. Space and time aren't things, that's the tools of the mind, and so they're starting to assign those physical properties. They're creating all of these dimensions, and some of these theories, they got 100 different dimensions. Some of them are curled up like soda straws at every point in space, and there's cracks and bubbles going through the pathways of the universe. It's just crazy. It's totally a sign of insanity. You can't just say that there are dimensions out there. What science is about is to explain in a way that's comprehensible to you or I, to us human beings, what is going on in the world. And I think that is where physics at this point has failed us. They're saying everything comes down to math. Well, what is math? Math is just simply a way to quantitate physical phenomena. It's not a substitute for them.
No, not at all. Now, is it possible that the universe is alive the way we think being alive might be?
That's a very interesting question, because it turns out, I don't know if you ever heard of the program Through the Wormhole with Morgan Freeman.
Oh, sure. Absolutely.
Yeah, actually, the 13th, June 13th, they have a show called Is the Universe Alive? And actually, I'm actually on there. and the answer is a resounding yes. There is no such thing as this inert object out there. And again, that is what, is at the core of biocentrism, and that is again, everything that you perceive is observer determined. And again, almost every experiment that has been carried out in the last 100 years has confirmed that.
Well, I think it's alive too, in some form or fashion.
Yeah, and there are many ways, and if anyone watches that show, there are I think a number of other scientists who approach it from a different approach as well, and arrive at the same conclusion.
To me, there's no question that if we're alive, and we are,
right,
we had to develop from something else that had the ability to have life.
Right.
And that's the universe.
Right. And I think that's what you were coming back to with the chicken or the egg.
Yeah.
You can't have one without the other. You can't.
That's right.
And so you can't have, they're interrelated, and one can't exist without the other.
I even think this planet is a living organism.
And it is. You mess with one part of it, and as we're going to find out very soon,
it fights back.
Serious consequences, yes.
Have you been hearing this story of this strange sound, this hum that's going all around the planet?
No, I haven't.
People are hearing it, Robert, in different spots. It's all over the place. And I think it's the planet reacting to something. It's this huge groaning sound.
Well, I have news for you. We're going to hear more than a hum pretty soon if we keep messing with it the way we are.
Sooner than later. Huh?
Exactly. And a very loud hum, actually.
Do me a favor. Where do you get your book, Biocentrism, and give us your website?
Okay, well, you can get it on Amazon.com, probably the easiest way. You can get it Kindle or paperback, and, maybe at most bookstores. My website, I actually have two. My main professional one is robertlanza.com, And then I have one just on biocentrism, which is Robert Lanza, biocentrism.com.
Are you related to the late singer, Mario Lanza?
I'm not, but actually my brother's name is Mario Lanza.
All right, stay with us. We're going to come back. Final hour with you, Robert. We're going to take phone calls, both on what you hear us talking about with biocentrism and also stem cell research, too. Jump on board. 2 different topics with Robert Lanza and your calls next on Coast to Coast AM. We're with Robert Lanza as we're talking about his theories of the universe. We're also talking about stem cell research. Can he clone a Neanderthal or a dinosaur? We'll take your calls with him next on Coast to Coast AM. Hey, Robert, can you clone a dinosaur? Is it doable?
Well, that's a funny question. I actually have a 6-foot brontosaurus bone at home that weighs 800 pounds, and it came from a dinosaur that was as big as my house. And the first question everyone asked me, are you going to clone it? You know, of course, we cloned the first endangered species, and what I tell them is that you can't clone from stone, that you need a living cell. So I think that the chances are slim that we'll be able to clone a Neanderthal or a dinosaur a la Jurassic Park soon. But I think that being said, I think that there are enough of a genetic match between the Neanderthal and humans, for instance, to solve many of the problems that currently exist. So one approach might be to start with human stem cells and then to change the regions of the DNA using techniques such as this techniques known as homologous recombination. And we might even have some success doing that today. I think the problem is that most of the tissues, say, from a dinosaur or a woolly mammoth, are severely damaged. The soft tissue in a dinosaur, for instance, would be so destroyed that it would be very difficult, if not impossible, to figure out its genome. But that being said, if we found some DNA, we might be able to use computers to guesstimate the genome, what it might have looked like, and we could then use that knowledge to fill in some of the gaps. And so, but again, a lot of that's going to depend on the condition of the DNA that we found. Bottom line is we're unlikely to see any dinosaurs in your backyard anytime soon.
Why would we want to clone a dinosaur? Just for novelty, to put in a zoo? Well,
that's exactly, one of the questions that I've raised with the endangered species, that unless the natural habitat, it still exists, that's all it would be. It would be a sideshow, and I'm not sure of the ethics of that. And I think the same thing would be is if you cloned a Neanderthal, there are very serious ethical questions there.
Yeah, exactly. What do you do with him?
Exactly.
Let's take some calls. We'll go west of the Rockies. Eddie in Seattle, Washington. Eddie, thanks for calling.
Thanks for having me on.
Sure.
I heard you comment about deja vu, and I wanted to kind of throw a theory out there for you and see what you thought about it. I once had a dream that the space shuttle blew up. My mom told me to call NASA, tell them about it. They told me they get calls like that all the time. The shuttle went up right after that. Nothing happened. Then the next one blew up, and it just seemed so real, and it seemed so real in the dream. Now, I call that a premonition when you see something before it happens, and I think premonitions and deja vu are related, and I think deja vu is seeing the past, and premonition is seeing into the future, and I think we have that ability because my theory is instead of being reincarnated into an animal or shape-shifting into an animal like some of the Native Americans may believe, or into another person, I think we come back as ourselves and relive our lives again, because I think we might be in a time paradox where in the future, maybe not the too distant future, something happens and everything explodes, and then all of a sudden time starts over again. And I just wanted to kind of get your comments on that theory, and I'll let you go to the next caller.
Yeah, well, I think your guess is as good as the next person's. I think our science is just so primitive at this point, I don't really know that anyone could really give you an answer for that. So, again, there's a lot we don't understand, and, I certainly don't pretend to have the answer for that question. I'm sorry.
Let's talk a little bit more about the cloning of dinosaurs, for example. And again, I agree with you on the ethical stand on that. It's like the island of Dr. Moreau. Mm-hmm. But somebody sometime is going to do something like that.
Right.
There's no doubt about that.
Well, I mean, we've actually, for a moment, we did resurrect an extinct species. So there's something known as the Bucado mountain goat. The last Thalia, who was the last Bucado mountain goat, died. Actually, it was the first mammal to go extinct this millennium. A tree fell and crushed her skull. Fortunately, the biologist had got a sample of skin from her before she died, and just actually a few years ago, they actually used a regular Spanish ibex, and they actually took frozen cells that they had, they thawed them, and they actually created this extinct animal. It was born. It died within minutes after it was born. I could have told them, and they should have some surface actin because we ran into that same problem. But for a brief while, that animal that had been extinct was indeed resurrected. I think that they're planning to repeat that. So we already have managed to take an extinct animal and resurrect it, however brief. So I think in the near future, we will probably see that actually happen.
Okay, next up, let's go to John, Lincoln, Nebraska, first-time caller. John, go ahead.
Yes, I was in a bicycle accident 4 years ago, and I suffered a spinal cord injury.
Okay.
And I was curious about stem cells or for neurocells.
Are they experimenting with that yet, Robert? Stem cells?
Yeah, actually, Geron, a company out in Palo Alto, out in California, actually was the only other company other than ACT that they got approval to use stem cells for spinal cord injuries, and they did initiate some safety studies on that. Unfortunately, that effort was abandoned, but there are indeed studies in animals where animals that have been paralyzed have been injected with stem cells, and they have been able to partially restore function to those paralyzed limbs. Again, in our particular studies that we just did recently, in what we call an EAE model, experimental autoimmune encephalitis, these animals become paralyzed, they lose function of their hind limbs and then the forelimbs, and an injection of our embryonic stem cell-derived mesenchymal stem cells actually was able to prevent that paralysis altogether. So there's a lot of different cell types that I think we might be able to use for spinal cord injuries in the future.
Okay, next up we go to Barry in Rock Hill, South Carolina, east of the Rockies. Go ahead, Barry.
Hello, George. What a wonderful pleasure it is to speak to you again. Last time we talked, it was about good old Ed Leapscommon down at the Carl Castle.
That's right.
Anyway, this is for Dr. Lanza. Is it L-A-N-D-S-A?
L-A-N-Z-A.
Z-A. Thank you for telling me because I want to know that. Can I get your email address from your website?
Yes. It could. One of them is Robert Lanza at yahoo.com. Okay.
Listen, I have macular degeneration in my left eye, and it's going away. I'm 69-year-old retired biochemist.
Okay.
And listen, aren't you at Wake Forest Bowman Gray School of Medicine?
I'm an adjunct professor there, yes.
Okay, yeah. Well, I'm only 2 hours away from you. I'm close to Charlotte, North Carolina. And I want to, my retinologist has given me Avastin injections in my left eye every 6 weeks, not to cure the macular degeneration, but to try to slow it down. And I am interested so much in trying to get to where I can be in Winston-Salem in 2 hours, and I would love to be some kind of research guinea pig to see if we can work out the stem cell thing that might help me and other people in the future. Is there any way I could get in touch with you and see about getting in something like that?
Yeah, well, for the moment right now with these FDA clinical trials, we actually have identified 4 sites, and those will be the only sites for the moment, and they include UCLA. We also have one up here in Boston, Mass Eye and Ear. There's Wills Eye and Ear in Philadelphia, then also Palmer down in Florida, and those are all the top eye institutes. So for the moment, for those clinical trials, you would need to be enrolled there. But for the next phase of these clinical trials, it may be more widespread, and then we may be able to do it, for instance, in Wake Forest or in that area as well.
Robert, if they begin to see astounding results, and I think they are, but will they speed things up for people?
Yeah, so what happens is the first step is do no harm. So they actually have us start out with very small numbers of cells in patients who are already legally blind, who already have very advanced stage. If we show they're safe, and as you're mentioning, we're already seeing efficacy that we shouldn't be seeing at this early point, they will allow us hopefully to go to younger patients where we'll hopefully see far more dramatic results. Because the goal of this therapy isn't necessarily to reverse blindness, but to prevent it altogether. So if we go into some of these patients, so for instance, in the next few weeks, we'll be treating patients for the first time with double the dose we started with. And if we see more dramatic results, I think, the pressure will be on to try to accelerate these trials.
Okay, let's go to Scott, Fort Wayne, Indiana, on the wild card line. Go ahead, Scott.
How you doing, George? Good to talk
Okay,
to you.
thanks.
I'm observing time on a PeopleNet system. I drive for a living, and I have a PeopleNet in my van, and I'm observing a second timer, and I'm counting 1,001, 1,002, and it's skipping 3, 5, sometimes 6 seconds ahead. How do you explain this?
Maybe you need a new battery. No, honestly, I can't answer that one for you. I'm not sure exactly what's going on there.
Is this the phenomenon that you're talking about, George? The time isn't time anymore. It's just skipping ahead.
It is. It is skipping way too fast. Maybe it's because you get older. Robert, I don't know.
Well, there are scientific studies that very, very clearly show that time as we get older subjectively passes, say, I think the number was up to 4 times faster than when we're young. So our perception of time as we get older actually very scientifically and objectively passes many, many fold quicker than it did when we were young. And that's a real phenomenon.
Okay, let's go to June in Lumberton, Mississippi on the wild card line. Hi, June.
Hello, George, and happy late birthday.
Well, thank you.
Thank you for taking my call. Mr. Robert, I was reading about the Mayan calendar that at the end of this year we could possibly go through a photon belt.
Uh-huh.
And if this is so, is this going to change our building blocks and our amino acids? And would our DNA change for a higher consciousness?
Interesting question.
Well, I hope they're wrong, because I certainly hope to be here next year. So, I don't know that's going to occur, but based on the scientific information I have, I think we're going to make it.
Will humankind change, though, Robert, if there's some kind of anomaly out there?
Certainly we know for a fact that, obviously evolution is based on mutations, is based on changes to our DNA, and anything that will change or accelerate that process will modify, the pace and the nature of evolution. So, yes, there are many natural environmental phenomenon that would definitely change the course of evolution.
When the asteroid hit 60-plus million years ago and apparently wiped out the dinosaurs,
right?
I find that hard to believe that every living creature would have died.
And it didn't. I think what you saw was it basically was one of the, sort of like a nuclear winter to some extent, and so it wiped out the larger animals, so that when you lost the dinosaurs, which were quite huge, went extinct. There were smaller animals. Humans, one of their predecessors, actually was a small rodent-like creature that actually eventually went up a tree. And so what it did is it created a niche that allowed for humans to evolve without the presence of dinosaurs. So it knocked out the larger animals on the planet.
If the dinosaurs weren't knocked out, would we be here?
Probably not. There's no way to know for sure, but certainly that allowed the other life on the planet to move ahead.
Do you agree with evolution, the Darwinian theory?
I think it's a considerable oversimplification. I think that it's sort of like a kid in the school. It's a nice story to tell, but I think there's a lot more to the picture. I think it's missing a very vital component, which is the observer, and without that, the whole reason for evolution is just missing. So the whole driving force of evolution is consciousness. Is that we are the force that basically allows these probability waves to collapse, as the physicists like to say.
All right, let's go to John, Huntington Beach, California, wildcard line. John, thanks for calling.
Well, thank you. First-time caller here, George.
Good
I think
for
you
you.
have a great show, especially with a person I know and I had a great pleasure meeting on a few occasions, Dr. Robert Lanza. This is John Ridelli. I'm a current shareholder in the company that Bob is the leading scientific officer, called Advanced Cell Technology. For your listeners, ticker symbol ACTC. I was hoping Bob might update us on the latest news and results regarding the patients that they are treating in the trials, when we will treat the very next patient, and what are the chances that we might treat Dame Judi Dench.
Hey, John, how you doing? Good to hear from you. So we've treated 7 patients as of today. We've been seeing, pretty stunning results as of today. We're hoping to do the first patient with twice the number of cells in the coming weeks. We actually have had some discussions about Dame Judi Dench. She would be a candidate. We actually do have a modification that the FDA has gone along with that would allow us to treat if one eye was dry AMD and the other one was wet, which is what her situation is. So we're in dialogue, and that's a possibility.
You also talked about developing synthetic blood.
Yes. So we actually have the capacity now to create entire tubes of red blood cells from scratch in the laboratory. And it turns out that they actually can transport oxygen like normal blood. And we actually now have a new line that is what we call O negative. So that blood that we make would be a universal donor. It would match virtually everyone listening to this program. So we now have those cells. We're making a master cell bank. And we've also discovered how to create the platelets, which, of course, are the cells that are responsible when you're in an accident for preventing clots. So we now can create those in a way that they form clots and are functional. So we're making significant progress making these red blood cells. We can make 100 billion red blood cells from one small 6-well plate of these embryonic stem cells.
All right, let's go to one more call before the break, and then we'll take final calls east of the Rockies. Brian in Whitley City, Kentucky. Go ahead, Brian.
Yeah, I was just wanting to make a comment on the random number counters.
Sure.
No one ever really correlates the fact that when they stop, randomness ceases to exist. And it's just one of my theories that there's a multiverse synchronization happening when these big events go on and these number counters start acting funny. And could you elaborate on randomness for me a little?
Yeah, well, personally, I think randomness and order are really opposite sides of the same circle. So it's just really a system of logic. So that when we say that things are completely random or chaotic, and then someone else says, well, no, everything is determined, I think we're really talking about the same information system. It's just what direction we're addressing it. And so I think that whenever we describe a phenomenon, we have to be very mindful that that's just the surface, and that the more we dig, the more we're going to find things, as I was mentioning to George earlier, about like knocking on a piece of wood. It seems solid, but the further we dig scientifically, the more we realize it's empty space.
We're going to come back with you, Robert. We'll take final phone calls on Coast to Coast AM. Lynn McTaggart joins us on our next Coast to Coast program talking about her work, the field. She's got an intention experiment she wants to conduct on one U.S. city, so you'll be part of that experiment tomorrow. And also our first hour, Ancient Aliens, Georgios Tsoukalos joins us. We'll be talking with him and how he thinks they may be going into year 5. More to come on Coast to Coast AM. Robert, will you continue to do experiments on biocentrism, or are you done?
Well, basically that's a theory, but there are certainly new experiments that will be carried out in the coming years. There's one known as scaled-up superposition that will test this at the level of human beings, so that if that turns out the way I would expect, that would be one of the strongest scientific experiments proving or suggesting that what biocentrism says is correct.
And it very well may be. And if it is, and if more scientists jump on board, what will that do?
Well, I think it's just going to basically turn the way we view the world upside down. I think everything from evolution to the Big Bang, we're going to have to rethink all of that.
Okay, let's go back to the phones. First up, let's go to Newport, Oregon. It's Simon or Simeon. Is it Simeon or Simon?
Simeon.
There you go, Simeon. Go ahead.
All right, thanks, George. Absolutely interesting show tonight. The time-space reality thing has always boggled my mind, and I just wanted to see if I could articulate this question enough correct, because the question itself boggles my mind. Is that if I'm sorry, are you still there?
Yep.
Yeah.
Okay. If with your example of the fabric record, if the past, present, future has always been there, then wouldn't that mean either that there has to be a reality or a space and time for every decision that every living creature that ever has been, is, or ever will be? There has to be something out there for that created, and are we continuously creating that, or is it already there?
Yes and yes. You're dead on both.
Okay, and so the other thing I was wondering as well is or if it is already there and we're just going through the motions of observing it so that it can exist.
Well, the way I like to think about it is like you're taking a ride out into the country. It's there, but you're exploring it, and so I think that's more or less what the scenario might be like.
Okay.
Simple as that. Simple as that. Okay, let's go to first-time caller Jason, truck driving in Canada. Hi, Jason.
Hi, how are you guys doing?
Good, Jason. Thank you.
That's good. Just bear with me here. I've never talked to 20 million people before, so. So I was just calling because I had a question. Has the guest ever done any research regarding consciousness and the relative to the left brain, right brain hemisphere phenomena, like what they've been investigating with the Monroe Institute for the last 50, 60 years? Because there was a really interesting video that I watched. A neurobiologist by the name of Jill Bolte-Taylor. She had a stroke, and it was in the left side of her brain. And when that happened, then she ended up basically, her right brain kicked in, and basically instantly her perception of reality changed. And she did a keynote speech on it. You could find it on the internet. It was very, very interesting. And so to me, it sounds like what you're talking about, and how basically what we perceive is what our reality is.
No, that's absolutely correct. I mean, there have been literally hundreds, if not thousands, of reports of injuries to the brain, or when you bisect the brain, you dramatically impact the perception of reality. There are all sorts of very weird phenomena that occur. So the brain, at least in terms of the way we understand it in terms of neurobiology, is very complex. So something as simple as just seeing something can be involve 10 different areas of the brain, and when you interfere with any one of those, you're going to alter that perception. And if you just think about it right now, as you look at anything, your eyes jerk around. You may close your eyes. You may move your head, but the world seems to stay stable. So there's all sorts of circuitry that allows you, even though you move your head, for the outside world to stay straight in front of you. But there are many, many components of this, and the left side of the brain definitely has unique features that differ from the right side of the brain. And when you divorce those or you alter those, you will alter perception.
As you were saying, if we get away from embryonic stem cells and go straight to the harvesting of one's own body, what is there to complain about? There's no argument anymore, is there?
Well, like I said, we can now produce embryonic stem cells without harming or destroying the embryo. We can now take blood or skin cells, as you say, without any controversy at all. There are no embryos involved, and I think even the Pope is on board with that.
And I would think that would be better, the fact that you can use your own stem cells, right?
Exactly, because you're bypassing one of the biggest problems, and that is immune rejection. So if they're your own cells, they're a genetic match, and then you can inject them without worrying about using these powerful immunosuppressive drugs that have very serious side effects.
Okay, back to the phones we go. Chris is in Palm Springs, California. Chris, thanks for holding. Go ahead.
Hey, how you doing tonight?
Okay, Christopher, good.
Yeah.
You
going to say anything? I guess not. So,
well, that was an easy question.
He needs stem cells. Let's go to Linwood in Jefferson, Texas, on the wildcard line. Go ahead.
Hi.
Hey.
I was calling to speak to the consciousness issue that was brought up.
Sure.
There was a book that I read a long time ago called Seth Speaks by James Roberts.
Oh, sure. Good book.
Okay, now in that book, basically the nature of physical reality is explained as follows. Consciousness manifests as ideas and emotions. Some ideas and emotions are perceived as objects which occupy a dimension we call space. Other ideas and emotions manifest or perceived as events in a dimension that we call time. And as physical beings, that's how we're wired to perceive reality, although a reality exists outside of our perception of it. I'll go offline for your comments.
Well, I think many of the mechanisms that you mentioned, I think, are correct. The bit about Seth, I'm not aware of that, so I can't speak to that end of it.
Though he is right about that.
The way he described it, much of that is correct, yes.
Charles in Hawaii. Hey, Charles, thanks for calling. Go ahead.
Sure. Hello. I'm wondering about the second law of thermodynamics because I studied it independently, and there's so much scientific belief in it. But if we could get rid of it, it would be so much more beautiful in the world. But that's not a legitimate reason to believe the second law of thermodynamics.
Well, I mean, it's the second law of thermodynamics that makes the whole universe tick, and so the good news is that's what makes life possible. So it's basically, we have systems that are running according to certain laws, and like I said, I think that is basically the way we connect things together, using the current paradigm in terms of an objective external reality.
What fascinates me about the universe, Robert, too, is everything's the same. The primordial soup that it probably could be found in our solar system, probably would be in other solar systems too. Mm-hmm. It's just carbon copies of everything, isn't it?
Mm-hmm. The same formative events that occurred in this galaxy, in stars and planets is occurring obviously in other galaxies as well.
Let's go to Allentown, Pennsylvania, and it is Roland there. Hey, Roland, go ahead.
Hi, George Noory. This is Roland.
Hi.
I'm a totally blind person. I've been listening to you for years, and I'm impressed with this Robert Lanza.
He's good.
With the stem cell research. I was a patient of Dr. Hal Mackenzie Freeman at Massachusetts Pioneer in the 80s to the 1990s.
Would you let me ask you, Roland, would you take stem cells now?
I would be willing to do that to regain at least some eyesight.
Good for you. One day, Robert, this is going to happen for him, isn't it?
Well, I mean, there are many components here. One is to use the stem cells to prevent the onset of blindness. The other would be to actually reverse the process, and we're seeing a little bit of that already in our clinical trials. Some of the other work we're doing is we have these stem cells that can turn into photoreceptor progenitors, and there's some initial work in animals that suggests that you may be able to connect those up to the eye after the photoreceptors are actually lost. And the existing paradigm is that once you lose those photoreceptors, it's irreversible, but that may not be the case.
Any other questions, Roland?
How about an artificial eye? My left eye is artificial. If they're not ready for that yet.
No, probably not.
But my right eye, I can walk up to the hood of my stove in my kitchen and turn the light on underneath there, and I see the light.
You can see the light.
Perception. Or go to the window and I can move my hand back and forth.
You can see that
on my face and see a shadow.
Yeah, you can see that movement.
Well, yeah, many, like I said, the first few patients that we treated could only discern hand motion. And after we injected the cells, they were actually able to start counting fingers and reading letters on the visual acuity chart.
That's dramatic. When someone is born blind, Robert, what has gone wrong?
Well, there can be many, many components. So obviously, everywhere from the beginning of the eye where there are issues with the retina all the way through to the brain itself where that circuitry, where that information is processed. So blindness can occur at any step in that pathway.
And stem cells could fix any of those processes along the way?
It's theoretically possible. We're obviously right now just focusing right now on the leading causes of blindness right now. So for macular degeneration, which affects 30 million people worldwide, we know the cause of that is the loss of these cells called the RPE, the retinal pigment epithelium.
That's Steve Wynn has that problem.
Retinitis pigmentosa, right. So, there's literally dozens of these retinal degenerative diseases, and they're all caused by the same reason. That is the loss of these RPE. And so what we're doing now is using stem cells to make new healthy ones. So we're going after that. But there are many, many other eye diseases that we're working on right now as I'm speaking to you, things called like uveitis and glaucoma. And we have cells right now that we're testing that we think can help those disorders as well.
James in Long Beach, California. Go ahead, James.
Hi, George.
Hi.
I'm very interested in this man you have on here. I'm a 22-year-old college student, and I've been listening to you for a few years now.
Thank you.
But my question is, have either of you, sirs, had any experiences with DMT or dimethyltryptamine?
Other than talking about it on the show, that's about it.
Well, I had the privilege of doing it or experiencing it when I was 20 years old, about 2 years ago, and you go into a bit of a trance, and although your body isn't, fully, aware or activated, your mind goes somewhere else, and I was wondering, is that like just an expansion of the dream world? Is that... does my consciousness create it in reaction with that chemical? I just wanted to know a little bit more about that.
So it's all the same process, and I think what many of the chemicals are doing is they're interfering with the process that you normally experience, and so you're getting very much like you get in the dream. And as I mentioned, it's the exact same phenomenon. In your dream, with your eyes closed, your mind is creating a spatial temporal reality. I mean, you actually are creating something that you're perceiving as space, even though you're in bed, and time. And so what you can do in many of these instances is when you interrupt that pathway, you will actually get a greater sense of what might really be going on that you wouldn't otherwise.
It is indeed a psychedelic.
Indeed.
Yeah, it is. Okay, who's next? We go to Mark in Park City, Utah. Welcome to the show. Go ahead, Mark.
Yes, I noticed we are always talking about reality. What is the difference? I work with a lot of handicapped people who are blind sometimes, but what's the difference between those who are blind and those who are possibly schizophrenic? How do you determine, well, I guess it's their own reality, but where do you draw the line between schizophrenia and the reality of it?
Okay, so there's two things. One is obviously, when you're dealing with one of the problems you're dealing with, blindness is a physical disorder where the light hitting your eye isn't being processed by the brain. So that's just simply a defect in the circuitry of your body. Schizophrenia, on the other hand, for instance, when I was actually in medical school taking psychiatry, I remember my first patient seemed completely normal, and then you'd have a discussion, and she'd say, "Well, Queen Elizabeth was she had a discussion with Queen Elizabeth in the morning, and she was in her bathing suit, and they were talking, and so that clearly, schizophrenia or schizoaffective disorders, that is where there's a distortion in your perception of reality, and to that person, that reality is just as real. I mean, just like A Beautiful Mind, the movie, to that person, those illusions are just as real as the table and chair that you sit on. So again, reality is very complex, and even your dreams is the same process as reality. So, but a schizophrenia clearly is an alteration of the way you're perceiving reality versus blindness, which is in most instances a physical disorder.
Kevin, Missoula, Montana, first-time caller. Kevin, you're on with Robert Lanza.
Hi, how are you doing?
Good.
Hi. My question is, it's kind of convoluted. I'm here at work and catching bits and pieces here, but I heard somebody talk about the space-time continuum, and then and kind of got to thinking when you started talking about neurobiology and stuff like that. I'm a social work and psychology major at the University of Montana, and I guess my question is how would you define or explain metaphysical perception, like something like astral projection?
I don't know if you can answer that. Can you, Robert?
Yeah, no, I can't answer that one. Sorry.
I'll take a stab at it, though.
Okay.
I think that truly there's something going on in the subconscious mind that allows people to, separate into their astral plane, their astral body. When we talk about the complexities of the universe, this is part of it. I mean, the body, the soul, everything that you want to talk about is included in all of this. It is, Robert, I think, even a much bigger picture than even most can comprehend.
Absolutely, and then some.
And then some, indeed. Only about a minute or so left. Again, tell us the website, where you can get your works.
Okay, my professional website is robertlanza.com, and the website for Biocentrism is robertlanzabiocentrism.com, and you can get the book on Amazon.com or at your bookstore.
Do you travel much? Speeches?
I do. I try to keep it to a minimum, but I do quite a bit, yes.
Well, people are interested in this, and also, of course, the stem cell research, which is going to get bigger and bigger and bigger. Let's just hope this country stays at the forefront. Are you there?
Yes.
Oh, okay. I thought you fell asleep on me.
100%. Yeah,
okay.
Absolutely. I agree with you.
All right, my friend. Be well.
Okay, you too.
Okay. Stem cells. You read all about it. You can go to his website, robertlanza.com, and one day they'll be able to do incredible things like growing noses. They're doing ears right now. Thanks, Robert. For Dan Galante, Tom Danheiser, Lisa Lyon, Lex Lonehood, Sean Ladesseur, Stephanie Smith, George Knapp, John B. Wells, Ian Punnett, and Art Bell, I'm George Noory, somewhere out there on Coast to Coast AM. We'll see you on our next edition. Until then, be safe, everyone.